In this video, we're going to go through lesson 4.2 to do some solving of linear equations, just a simple introduction, and then we'll step it up in the next few lessons with some more complex examples of solving linear equations. So before we begin and jump in, we're going to do a quick review of like terms. So remember that like terms are terms that have the same variables. In addition to having the same variables, they also have the same exponent. For example, x squared and 2x squared are like terms because they have the same variable, x, this is the same variable, and the variable has the same exponent, 2 and 2. If you add something like x cubed, 2x cubed, let's just say, and 3x squared, 3x squared, these would not be like terms. Because if you look, yes, they do have the same variable, but the exponent is different. So they are not like terms. And we've seen that already. Just if you forgot this, go back and review that from the previous chapters. Remember that we can actually simplify expressions by collecting like terms and adding them or subtracting them. So for example, if we look over here, we have 3x plus 5 minus 2x plus 3. We can group the like terms together. So we can write this as 3x minus 2x plus 5 plus 3. And we can perform the operations that you see. So 3x minus 2x is 1x. We don't have to write the 1, it's implied, it means we know it's there. And then 5 plus 3 is 8. So that's plus 8. So that's an example of how we could simplify expressions by understanding what like terms are. Again, same variable and same exponent in order to be considered like terms. So now we're going to take a look at what an equation is. We're going to give a formal definition for it, and then take a look at what we can do with equations when we have them. So an equation is a mathematical statement where the value on the left side of the equation, is the same as the value, on the right side. Of the equation. So, for example, this is an equation here. I can write x plus 5 is equal to 15. What that means is, this is my left side over here, left side of the equal sign, which is over here. X plus 5 on my left side is going to be equal to 15 on my right side. So what that means is, x has to be a number so that when I add 5 to it, it's going to be equal to 15. So if I ask you to solve an equation, what that means is I'm asking you to find the value of the variable in this case being x, of the variable, that makes the equation true. So if I were to ask you for the solution for x plus 5 is equal to 15, you need to find the value of x that makes x plus 5 equal to 15. And most of you in your head could figure out, okay, that's probably going to be 10. So you might have found that in a variety of different ways. Some of you might have said, well, all I have to do is 15 x is equal to 15 minus 5, and that would be my value of x required to make x plus 5 actually be 15. So we're going to take a look at strategies to solve equations. And again, when I ask you to solve an equation, it just means find x, find the value of that variable that makes that equation actually true. So to solve an equation, you must first isolate the variable. This means that you really need to get the variable by itself in the equation. So to isolate a variable, what you need to do is something called opposite or inverse operations. Opposite another term is inverse operations. So basically, if I say addition plus, its opposite or inverse would be subtraction, minus. If I say multiplication, its opposite or inverse would be division. And that goes two ways. If I say division, opposite inverse means multiplication. If I say subtraction, opposite inverse means addition. So there's a few different ways that you can solve a linear equation. We're going to go through the different methods that you can use. And then afterwards, we'll do a few examples together to make sure you understand the concept. So the first way is solving by inspection. It's basically by intuition, by your knowledge of addition or subtraction or operations. So suppose I gave you x plus 4 is equal to 13 as the equation, and I want you to find what x is. I want you to solve this equation, solve for x. Well, in your head you'd think, what number plus 4 gives 13? Well, you know that's 9. So that's by inspection. Another strategy that you can use is solving by balancing equations. You can kind of think of the equal sign over here like a balance. So the left side is x plus 3, and the right side is equal to 7. You can see that there's a little envelope here with x number of circles in it. We don't know what that is. And then 3 circles. We know for sure there's 3 being added to that envelope. And over here we have 7 circles. So what you can do is you can isolate x. You can get the envelope alone by removing the circles that are on this side over here. So you can remove 3 circles. But you want to keep the balance the same. You don't want it to tilt to one side or the other. So to make sure that it remains balanced, you have to remove 3 circles from both sides. And so what you'll notice is that there's 4 circles left. So that what that must mean is that there must have been 4 circles in this little envelope over here. So the solution here is 4 circles. You can take a look at the math playgrounds for some simulations based on this over here. But that's just another way to think about how to solve for x. So we saw solving by inspection. We saw balancing equations to solve. Now we're going to go and take a look at how to solve using the inverse operations. So as we already mentioned, if you have addition, the inverse of subtraction, so plus, minus. If you have multiplication, the inverse is division. Now when you do inverse operations and you're trying to solve for a variable, you also need to make sure you're doing BEDMAS backwards as well. So normally you have brackets, exponents, division, multiplication, addition, subtraction. Now you're becoming SAMDEB, subtraction, addition, multiplication, division, exponent, and brackets. So that has to be performed backwards as well. And the idea is that whatever we do to one side of an equation, you need to do to the other side as well. Otherwise, if you change only one side and not the other, your equation isn't true anymore. The left side isn't going to be equal to the right side. So if you do something to the left side, the right side gets jealous, you need to make sure you do the same thing to the other side as well. So we're going to do an example where we do inverse operations. I'm going to do an example that you did above, actually, by inspection. So the example that we had done by inspection was x plus 4 is equal to 13. And our goal is to isolate x, to get x alone. And I'm going to use the inverse operations method. So to get x alone on the left side, ls, I'll call that ls, left side, I do x plus 4. That's already there. The opposite of plus 4, the inverse of plus 4, is minus 4. Equals. Try to make sure that your equal signs line up. 13, remember whatever you do to the left side, you have to do to the right side as well, minus 4. So now what's going to happen is 4 minus 4 is 0. So x is going to be equal to 13 minus 4, which is 9. So there we did an example of solving for an equation by doing the inverse operations. There's a few more examples over here that we can do together by doing the inverse operations of addition and subtraction. Try them yourself first, and then check to see that you were on the right track with the proper steps and the answer as well. So here we have x minus 8 is equal to 2. So what I'm going to do is the inverse operation of minus 8. So x minus 8, the inverse of taking away 8 is adding 8. Is equal to 2. And I have to add 8 to the other side as well to make sure whatever I do to one side, I do to the other as well. Minus 8 plus 8 is 0. So what I end up with is x is equal to 2 plus 8, which is 10. And if you go and double check your work to make sure you're right, you can see it makes sense. If you replace x by 10, 10 minus 8 actually is 2. Let's try b over here. So the inverse of adding 8, again, is the inverse of adding 8 this time is taking away 8. So we have m plus 8, take away 8, is equal to 11. Since we took away 8 on the left side, we need to do the same thing on the right side, minus 8. 8 minus 8 is 0, so we have m is equal to 11 minus 8, which is 3. Let's go and take a look at example C. For example C, we have minus 4 plus x is equal to negative 1. The opposite of minus 4 is plus 4. It looks a bit confusing because we wrote our variable second rather than first this time, but it's the same sort of idea. The opposite of minus 4 is plus 4. So we're going to do minus 4 plus 4 plus x is equal to minus 1. And we added 4, so we need to make sure we're doing the same thing on that side there too. Plus 4. Minus 4 plus 4 is 0. So we have x now. X is equal to minus 1 plus 4, which is 3. So our x is now positive 3. Let's try example D. Same idea. What is the opposite of minus 9? Well, that's plus 9. So we do minus 9 plus 9 plus h is equal to, what do? We added 9, so that means we need to add 9 on the right side as well, plus 9. Minus 9 plus 9 is 0, so we have h alone now, is equal to minus 6 plus 9, which is 3.